Hello and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of identifying prime and composite numbers. This is standard 5.4a in the great state of Texas, and we are using item number 15 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have 4 students. They're each writing down a number between 30 and 40, and we've got our numbers right there, Ellie, Ulysses, Maggie, and Palmer. The list shows the number they wrote. We need a prime number. Well, it's going to be kind of hard to figure this out if we don't have a good idea of the difference between prime and its counterpart, composite. So prime numbers, 2 factors only. And those 2 factors are 1 and itself. So let me give you some examples. Prime number would be 2. The only way to get to 2 is 1 times 2. Prime number would be 3. The only way to get to 3 is 1 times 3. Can't break it down any farther. Composite is going to be 3 or more factors. So it can be 3, can be 20. Perfect example would be 4. 4, I can get 1 times 4, but I can also use 2 times 2. So 4 actually has 3 factors, 1, 2, and 4. Even though there's 2 2's, you're only going to list it once. So what we use for this is prime factorization. And let's just start with Ellie. Let's start with 35. And we're going to think, are there any ways that we can break down 35? We could do 1 times 35, but that's not going to help us. That would give us back to the same problem. Well, take a look at the ones place. When in doubt, if the ones place has a 5, you can always multiply by 5. So look at that. We've got 5 times 7. Now, 5 is prime, and 7 is prime, because the only way to get to 5 is 1 times 5. The only way to get to 7 is 1 times 7. But since 35 has got more factors, we're going to say is composite. I'll list it here, because 35, you can always do 1 times itself. But composite numbers also have another option. In this case, 5 times 7. So 35 is composite. I'm going to put a C right there and cross it off. Let's check Ulysses. This is kind of a tricky one. 39. Well, it's not even, so I can't divide it by 2. Doesn't have a 5 in the ones place. Let me show you a little trick. It's called the divisibility rule. So the divisibility rule of 3, divisible by 3. What you do is you take your number. So I've got 39. You add them up. 3 plus 9. That makes 12. Is 12 divided by 3? Yes. So can 39. It works with the largest numbers possible, like 300, and let's see, that's going to be 312. Guess what? 3 plus 1 plus 2, that makes 6. Is 6 divided by 3? Yes, it is. So 312 is divided by 3. So let's take a look at our 39. We're going to do 3. That ends up being 13. 3 times 12 is 36. Add another 3, gets you your 39. That's your 13. 3 is prime. 13 is also prime. The only way to get to 13 is 1 times itself. So this is composite, not looking for it. Maggie says 37. Well, it's not even, not divided by 5. Let's try our divisibility rule. 3 plus 7, that makes 10. Nope, not divided by 3. Can't be divided by 4 because those are only even numbers, so guess what? 37's prime. So let's just make sure our 33 is composite. And look at that. 3 times 11. 3 plus 3 makes 6. That's divided by 3. So even though we've got 3 and 11, it is a composite number because it could be broken down in another way. So our answer is going to be Maggie's 37.